Today we will learn or discuss about the TensorFlow input pipeline. Let's say you're building a cat and dog image classification model. These images are saved in your hard disk and you want to load these images into RAM. By converting it into some kind of NumPy array or pandas data frame, you will have to simply convert these images into numbers, because machine learning models can only understand numbers, not images or text. Now you convert the data into a NumPy array and have got an X train, Y train, and you give it to your model for training. Things are looking fine when you have 1000 images. What if you have 10 million images? In deep learning, you usually have a lot of data. So when you try to load this on your computer, which has only 8 GB of RAM, your computer won't be able to handle all this computation. One approach for tackling this issue is about dividing the data into batches. This will be a special data structure, not a NumPy array or pandas data frame. So the way you do batching is, for example, you have a 10 million image data set. So you will load 1000 images into your RAM from your hard disk, load it, then you will do the second batch of 1000 images, third batch of 1000 images, and so on. The special data structure which I talked about previously is called tensorflow.data.dataset, and this is what helps you build your TensorFlow pipeline. And in order to build this, you need to use tf.data API framework. Now what if you have some blurry images? Before you use your data for anything useful, you will first need to clear out the blurry images. You need to do data cleaning, scaling, apply certain transformations, etc. Luckily, TF dataset, TF being short form for TensorFlow, has a lot of good APIs to support the transformations. You can use the filter function to detect whether an image is blurry or not. You can have a customer filter function which will filter out the blurred images before doing model training. You might want to do more transformations like scaling. So all the values for images will have three values, which will be the RGB channels. The usual practice is to scale these numbers by dividing it with the number 255, because the color ranges from 0 to 255. For this, we can use a simple lambda function which will divide x by 255. After this, you can use TF dataset to do filtering, mapping, shuffling, all of these different transformations. And we can do all of this in a single line of code by using the following syntax. TF underscore dataset equals tf.data.dataset.list underscore files, rounded bracket open, in single quotes your images, where your images are stored, so the directory. If you've stored it in the working directory, all you need to put is the file name, dot map, process underscore image, dot filter, filter underscore function, dot map, lambda x is equals to colon lambda x colon x upon 255. The dot list underscore files will load the images from the images folder. The dot map will convert the image content to NumPy array and extract label from the folders. Dot filter will filter blurred images, and dot map lambda will scale the values. As we have put x upon 255, so it will scale the values by 255. Next step would be to train the model by supplying TF dataset in model fit. Now previously we used pandas data frame or NumPy array. We used this for the model training, but this time we are using TF dataset. We can load text files, Excel sheets, we can load data from cloud, we can do pretty much anything with the TF dataset. And what we are going to do is we can use this data input pipeline to do batch loads, shuffles, filters, mappings, and all of this is called ETL, extract transform LAN. And in the end you get your TF dataset. You can directly feed to your TensorFlow model. There are two benefits in TensorFlow input pipeline. One is that it can handle huge datasets by streaming them from the disk using batching, and second is that it can apply transformations to make dataset ready for model training. Let's first import TensorFlow. So import TensorFlow as TF. Daily sales numbers equals 21, 22, minus 108, 31, minus 1, 32, 34, 31, any random numbers. tf dataset equals tf.data.dataset dot from underscore tensor underscore slices daily sales numbers. So there are some errors in the data that I mentioned, because of course sales cannot be negative, and they cannot be negative by $108. So let's first see our data. So for sales and tf underscore dataset dot as underscore numpy iterator print sales. Now let's exclude the negative sales records. So to do this, we will use the filter function. So tf underscore dataset equals df underscore dataset dot filter lambda x colon x smaller than x larger than 0 for sales and tf dataset dot as numpy iterator print sales. Now suppose you are working in India and you want to first convert this data, which is in US dollars, to Indian rupees. For this you will do tf underscore dataset equals tf dataset dot map lambda x colon x into 72 for sales and tf dataset dot as numpy iterator print sales. Now what we did was we multiplied every record by 72 using the mapping function. So tf underscore dataset equals tf underscore dataset dot shuffle by 2 for sales and tf dataset dot as numpy iterator print sales. Shuffle will just randomly reposition every element in our data. The 2 is being used as a buffer, so it will, you randomly shuffle every which element by how much. So for sales batch in tf dot underscore dataset dot batch 2 print sales batch dot numpy. By using batching, we are distributing our batches on different GPUs for training purpose. I said we did tf underscore dataset dot batch 2, so we are batching every 2 records with each other. You could batch more depending on your requirement. If you want to do all the transformations we did previously in one shot, use the following code. tf underscore dataset equals tf.data.dataset dot from tensor slices daily sales number. tf dataset equals tf dataset dot filter lambda x colon x larger than 0 dot map lambda y colon y greater y into 72 dot shuffle by 2 dot batch 2 for sales and tf datasets dot as numpy iterator print sales. Let's import our images from the directory. Images underscore ds equals tf dot data dot dataset dot list underscore files images, which is simply the directory in which your images are stored, or if they're stored in the working directory, the file name. Shuffle equals false. For file and images underscore ds dot take 3 print file dot numpy. So here we will get the first 3 file paths. So images underscore ds equals images underscore ds dot shuffle 200 for file and images underscore ds dot take 3 print file numpy. We now have shuffled all the data randomly. Now let's declare our class names. So class underscore names equals cat comma dog, train size equals integer image count into 0.8, train underscore ds equals images underscore ds dot take train size, test underscore ds equals images underscore ds dot skip train size. So we are using the take function for the first 80% of the samples and giving them to the training samples, to the training set, and giving the test the remaining 20% by using the skip function, which skips the first 80% and directly hops over to the final 20, which are the leftover 20. Now let's define our labels and file paths. So def, which is for defining a class or function, get underscore label file path colon import os parts equals tf dot strings dot split file path os dot path dot sep is short form for separator, return parts -2, get label, and we could just give it any random label. Above we are just splitting the file path to attain our label. To do so, we are taking the second last element. Every comma separated value or word has an index. The last element is -1, the middle one is -2, and the first one is -3, because we're going in negatives. If we went in positives, it would be opposite. The first one would be 1, the second one would be 2, and the last one would be 3. Now def process underscore image file path label equals get label, image equals tf.io.read underscore file path, image equals tf.image.decode jpeg, image equals tf.image.resize, return image and label, image comma label equals process image, and we can give it any file path, image.numpy. In this, we are simply getting our 3-dimensional arrays of the labels and actual images converted to numpy arrays. We are also resizing all the images to a standard shape. also while decoding the JPEG so the machine can actually understand. So train underscore ds equals train underscore ds dot map process image. Test underscore ds equals test underscore ds dot map process image. For image label in train underscore ds dot take one colon print, we can put anything like 4 stars comma image print 4 stars in double quotes comma label. So here we just take our train and test sets and then separate the image arrays and the labels so that we can understand which array has which label. Now let's define our scale. Def scale image comma label return image upon 255 with the label. Train ds equals train ds dot map scale for image label in train underscore ds dot take 5 colon print 4 star image colon image dot numpy and same for label. Now we have scaled the data and have completed our TensorFlow pipeline creation.